Thanks to PCB for sponsoring this video. In the last video, we saw that This Is a Party had a couple of problems, and in this video, we're going to try and fix at least some of those. So what problems are we going to focus on exactly? Well, first up is the wheels. The wheels kept getting hit sideways and having the rubber come off them, leading to no traction and the robot being out of alignment. Secondly is the electronics pack. It was too tight inside the robot and I broke a component off of a motor. Third up, we had the fact that I was not landing the hits that I really thought that I should be landing. And fourth and finally, we have the fact that the motor mount actually broke. We're going to start with some wheels, and in the last video I said that I didn't think I could do better than the Pololu wheels. This is a Pololu hub sitting at about 2.5 grams. I've now designed and printed my own hub that actually sits just under that, about 0.8 grams underneath that. Now, this is a ABS printed hub that is designed with some fins with perforations around the edges, so that hopefully we can mold in place some polyurethane and it will just stay there without the glue needing to do most of the heavy lifting, which is the problem I was facing with these. The big thing to work out now is whether these polyurethane, the amount that I need to make a wheel out of this, is going to be heavier than the silicone or rubber that is on the Pololus. So we might as well do a cast of that. And of course, if it's good enough to do one, we might as well do a lot. And done. Look at this thing. It is now encased in a polyurethane tire. This is specifically a 45A Shore polyurethane. I was going to do a 20A Shore polyurethane, but my 20A Shore looks like this. But now we need the all-important weight test. The Pololus are 4.3 grams. Let's take a look at these. 2.8 grams. Hell yes. We're actually saving weight by fixing this problem, or hopefully fixing this problem. All right, I think that is unequivocally the solution to this. So let's get these on the robot and then start talking about our next couple of issues. Okay, so problem with electronics pack is our next issue. And I mean, honestly, this is pretty easy to fix, I think. The big issue stems from this little plate here. This little plate is there to hold the electronics in and keep them underneath the guard, the weapon guard that I've printed into this chassis. It's actually easier to see on this version of the chassis. You can see that there is a little lip there. It's basically just glued in place. Unfortunately, that limits the amount of space I can put actual electronics in this thing, and honestly, it's just realistically a bad idea. The easy fix for this is to, in the print itself, raise these walls up, make the actual weapon guard a full height thing, which means I can pack the electronics to the very, very top of the robot and not ever worry about them slipping past the guard and into the weapon, which is definitely what happened last time. Issues 3 and 4 are bad hits and breaking motor mounts. Now, some of the comments out there from the last video suggested that these two were linked, and the fact that I printed the motor mount meant that there was too much flex, meaning I wasn't getting a good hit, and it was also the reason why it broke. And this is where PCB comes in. So PCB have made me up a whole bunch of PCB motor mounts. These I'm hoping to use to replace the carbon fiber drone arm. I had looked at maybe doing one on each side, so doing two up like this. However, the actual motor shaft is not long enough for me to do that. You can see the captive nut, or the nylock nut, is only just, like the bolt is only just out of that, so I can't actually put a bearing on this other side. So we're just going to have to do single support. For now, I don't know if 1.6 mil of fiberglass, which is effectively what a PCB is going to be strong enough to hold this. But there's one way to find out, and that is to mount this up. The other thing here is that I honestly have been looking at this design and I think that there is an issue in the front wedges as well. So the problem here is that because the thing is printed flat and then leans forwards, only the frontmost pieces of the plastic actually touch the ground. So while these scoops look great, they don't touch the ground, especially not at the back here, as the whole robot leans forwards, and I can kind of demonstrate that a little bit better by taking some foam here. Now, if I push this foam flat to the ground, and push it into the wedge. Hang on, let's do this in a different way. Hold the foam flat to the ground, push it into the wedge. It rides up the wedge. But I push it flat into the ground and try and go in from here, it very, very easily slides under the wedge because there is a gap there. So that means that my opponents, all they need to do is come at me from this angle and they get underneath me easily every single time. So the obvious and very easy solution to this is to extend this wedge out this way and kind of reduce this slanted section, because this slanted section, just by the very nature of the design, is never going to touch the ground. So we need to minimize this and maximize this where we're actually touching the ground. And there it is. So we've now got somewhat of a design evolution of This Is a Party's front end. And as you can see, I've just been progressively adding more wedge. So really it is just kind of a sequence here. Now the PCB motor mount just slots into this section right here and should seat down pretty nicely. That is not seated all the way down. Okay, yes it is, there we go. Now I've designed this currently to only house one. I did a bit of weight checking off camera and I can actually have two of these in here before I reach the weight of the old chassis with the 3D printed version. So if this is not stiff enough, if we break this, I can just print a new chassis that accepts two of these and everything should work then. We'll double the strength of our motor mount effectively. Now, normally this motor mount would, should go in here using a two-part epoxy of some kind, something really strong and stable that will grip really, really well. However, the only two-part epoxy I have right now is 24-hour cure, and I am feeling very impatient, so we're just gonna super glue this boy in for now, just to get some hits off, see how this all goes. And look, I will probably reprint this whole chassis and epoxy in another one for the final competitive design, but for right now, I just wanna hit something today, and so, yeah, we're gonna use some super glue. All right, so that is now attached in there, but just to really confirm this bond, I'm gonna use a trick that you guys have probably seen me use before. This is bicarb soda in a squeezy bottle. I'm just gonna run some super glue down this front edge and then throw some bicarb soda in it to set it up instantly and also create like a fillet bridge effectively. This also get in those holes a little bit and just help everything out, hopefully. Should I open the bicarb before I did this? Does make a bit of a mess, but that is why I've got the silicone sheet down underneath so I can just tap this off and then throw the bicarb in the bin afterwards. But that creates a much more strong and stable bond, and we're just going to do that on both sides here. And there we go. With that done, it is now just time to transfer the electronics from here into there. But look, that's just a couple of bolts, and you've seen me build robots like this before, so let's skip straight to the good part. Well, that worked out a lot better than I expected. Those were some really decent hits out of This Is a Party, so I am really quite happy with that. The only thing that really kind of happened there was that the first clip that I actually cut out, but you can see it now, I had a drive issue on one side and it kind of persisted through into the actual main testing that you saw. The right side is just a little bit not working, so I don't know if that's the actual DF robot motor itself or the ESC on it or something, I don't know. I am thinking I might move This Is a Party over to a Malinky at some point in the near future, but I couldn't actually find the Malinky I had for this video, so I decided not to put it into this one. But like I said, it might happen between now and the next event that I go to. Having said all of that, this is working way better than it was before. This is a kind of 200 gram-ish test chassis, and it was throwing this around no problem. So I think that we're going to be good for the issues that we were facing in the last video. Of course, the only real way to work this out is to actually throw it in the arena and try it. I don't know if one PCB is going to be strong enough. I don't know if these wheels are going to be resistant to horizontal hits. All of that is yet to be determined, but I'm feeling pretty good about where we've got to. So yeah, I think that is going to be it for this video. I hope you have enjoyed that one, and I will see you in the next video.